You're listening to Inside iOS Dev, show about real-world iOS development. Today with you, your hosts Alex Bush
and Andrew Rohn.
And we have a special guest, Kyle Roucis.
Roucis, yeah.
Kyle, please introduce yourself.
Hello. I'm Kyle Roucis. I'm an iOS developer who's been working with the iOS development kit basically since it was announced. Wow, when was that? Like 2009? Something like that?
Somewhere around there.
Man, are we getting old yet? Anyway, so I've dipped and dabbled both in Android and in iOS, and iOS is really my passion, and I love Swift. So I would love to talk to you guys about that.
Awesome. The one specific topic we wanted to chat about, I guess, Kyle, you and I, as we were working on the app, we talked about it, right? And we decided, that's a bigger conversation, so let's bring it up to our listeners. And specifically, it's Swift sets.
That's right.
Why you should use them.
Right, not to be confused with setters, which are a part of properties and stuff like that. Swift sets are actually a collection type that are sort of in parallel to arrays in Swift.
Right. And I guess this day, like what I've been noticing and kind of what sparked this conversation for you and I, people usually use arrays or something like that for like an ordered list.
Yeah, well, as we had discussed, people don't use sets in Swift, I think, as often as they should. I think it's a little known collection type, but it has a lot of power under certain circumstances, and I think it should definitely be in your listeners' toolbox when they decide to go build something.
So what would be the circumstances and cases where you would want to use that rather than an array or even a dictionary, right?
Right. Well, I would say that sets are a great option if you want to do things like option lists, right? So you might, under some circumstances, have like an enum that says like, I want this thing to be on and this thing to be on, and if this isn't passed in, then everything else is off, right?
Okay.
So sets are a great choice for doing that because they don't allow duplicates and their order doesn't matter. So if you wanted an option set, say like, okay, I want the lights on and I want the refrigerator on, but I don't want the sink on or something like that, just as a silly example.
Right.
Right. You could just add lights and refrigerator into that set, and your function will then take care of just looking through that set to turn on the correct things, and then everything else it'll turn off.
So when you say option set, is that I've never heard that before. Is that something that you just describe it as, or?
Yeah, it's colloquial, I guess.
Okay, just like a set of options.
Yeah.
In this case, on or off,
Correct.
basically. Okay.
Yeah. So there are some UI kit stuff that uses this as well. Sets come from with us to Swift, I suppose, in the form of NS set, but
right.
In Objective-C, NS sets are even harder to use than they are in, say, Swift. So people didn't use them very often.
I think one time I used it was core data. I was doing something with the relationships or whatnot.
Yeah, some of those are described in sets.
Right.
So using sets in Swift, I think, is really easy. Swift's approach to building sets makes them much more approachable than in Objective-C. So while dictionaries and arrays in Objective-C were given the syntactic upgrade with the @ and then open bracket and
the
stuff.
literal syntax.
Yeah, the literal syntax. Sets never got anything like that. Whereas Swift, they're really easy to build. You just specify your set type, and then you can actually build it using the array syntax.
Right.
So they're nice and accessible, they're very easy, and they work great with pattern matching. So for things like options, you can easily pattern match against your sets and be able to say like, okay, under the circumstances that this is in the set, and this is in the set, and this is in the set, I'm going to turn all of these on, or do these things.
By pattern matching, what do you mean by that?
Can
you unpack that?
So switch statements in Swift.
Right.
So the pattern matching paradigms in Swift that have come from its functional background are extremely powerful. In fact, I almost never use normal if-else statements anymore. I use the switch statements and pattern matching almost exclusively these days.
Like the sound of that.
I like the sound
tell
of this
us
a lot.
more.
Can you give me a concrete example? Because I'd love to get rid of the if-elses.
If
Right.
else is if evil.
Well, it does have its place. Sometimes a switch is too heavyweight, but let's say I want to do something based on the count of an array.
Mm-hmm.
You could do if blah.count equals something, right? And then else if blah.count or whatever, right? But instead, you should probably do a switch blah.count case 1 or whatever and run on from there. And then if you need to do something that's not caught by that, you have a default, right?
Mm-hmm.
But that same structure, that same switch case default, can be used for tons of things like tuples, arrays, dictionaries, sets. What this pattern matching is being able to crack open the items and collections that you put into that switch statement and be able to actually check, hey, what's actually in here? Go to that case and run this code, right?
Mm-hmm.
It's much more declarative, much clearer way of talking about like, hey, these are the things I want to do under these circumstances, instead of having the pyramid of doom that has been what Swift has been all about avoiding.
I'm wondering, couldn't you just do this with an array? I guess you get the disadvantage of you have to search through the array to look up the item.
Going back to sets, right?
So set is constant time lookup, right? And so you use this pattern here where you said like with the pattern matching, couldn't you just do the same thing with an array?
Yes and no. So one of the benefits of an array is that one, the types have to be hashable, right? So under the circumstances where you might choose an array, there's basically 3 criteria you should be using.
Okay.
The type is hashable. So pretty much all of the basic types in Swift are already hashable. So they're very easy to build and use. The big one that separates sets from arrays is they're guaranteed to not have duplicate entries.
Oh, okay.
So
Right.
that's really the big
I get
twist.
it. Yeah.
So you can specify duplicate entries in their construction, but part of the set's logic is to just throw away duplicates.
Right.
So you're guaranteed to have a minimal set every time, which makes them great for pattern matching. Right.
I see.
Because if you were to pattern match, say, against an array, oops, I accidentally added it one more time, and now that case is skipped. Similarly, the pattern matching for sets doesn't care about order. And in fact, if you don't care about order, sets are a great way to go, right? So arrays, if you pattern match against the contents of an array, it will care about order because order is important for arrays.
Right.
But for sets, that's not true. And they're very useful in that manner. So the other night, just preparing for this talk, I tried to figure out what the rules are around specifying patterns to match against sets, right?
Right, because you said that there are a bunch of things you can have in there, like tuples and other stuff, right?
Correct. And
I would assume it's different for those scenarios.
well,
Maybe
yeah.
not.
So the way you would pattern match against a set is you pass it into the switch. And then in your case, you would actually have the array syntax of the elements you're expecting in that list, in that set, excuse me. But I found that it doesn't matter what order you put the elements in there, because sets are unordered. It will simply execute the first one that meets the criteria of all of the stuff being in there, right? So again, if say we want to do our lights on and refrigerator on,
Right.
but not have the sync on in there, we would say switch on my options, case, open array, lights refrigerator, : right? And that would say like, okay, it doesn't matter what order those two have been added, as long as they're in there, you'll execute this code.
Okay. So the light and what was it? Light and refrigerator switch case is hit, and then whatever code you specify in that block is executed, and that's a cleaner way of writing the code instead of having the if-else's everywhere.
I think so, yes.
Okay.
Because otherwise you'd have to have a bunch of different if-else's being like,
right.
if my options dot contains lights, do this. If my options blah, 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 do this. So you can use the switch statement intelligently to potentially fall through to other cases as well. So if you want to build this, not quite pyramid of death, but pyramid of cases, let's say like, okay, when it's an empty set, what do I do? If it's only one element, what do I do? Okay, well, if the next case in there contains that element and one more thing, you can always say like, oh, do that and then fall through to the next case.
I have a question. So in the lights on in the refrigerator case, what happens if you have a case above that comes before that? That's the lights on case. Wouldn't it only execute that case? So is it just a matter of making sure that you order your cases correctly? That way it'll do the lights and refrigerator on case, not just the lights on case.
Yeah, that's what I'm saying. Is you can set them up in order.
Okay.
To intelligently fall through to other cases, and that's on a bit of an advanced side, and I'm not sure I would actually recommend doing that without a good understanding of how switches work and how pattern matching works in Swift, but it's a possibility. It's a solution.
Of this pattern, I agree. I feel like this is cleaner. I feel like, though, if you don't get the switch case correct, you might put something in the wrong order and then you execute the wrong block of code because you didn't put them in the correct order. Am I thinking about it wrong?
You might be coming at this from the C side of things, with like the Objective-C side of things, where if you don't put break at the end of your switch case, it continues to the next clause.
Right.
That is not true in Swift. So Swift is much safer. It's you have to explicitly tell it fall through to the next case. Right?
Okay.
So I think that's the mindset you're coming from.
Okay.
Objective-C unfortunately inherited that problem from C.
From C, yeah.
Among other things, but
that's another podcast episode.
Yeah. But yeah, in Swift, the fact that it doesn't automatically fall through to other cases actually makes pattern matching a much safer, much more powerful, much more expressive way of doing things than, say, in Objective-C.
If I'm not mistaken, with all this pattern matching in switch cases, you can also do the let unwrap for optionals, if those are optionals.
Yeah.
We talked about it on the last episode.
Correct, yeah. The pattern matching can unwrap things as well. You can do specific types in pattern matching. So you can say like case let my thing as this type, and it will check, okay, is it actually that type? If it is, I'm going to bind it into my thing. So instead of having to do it in if let blah, 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 right? You can actually just switch on the item itself and then use that case to do the binding, which I know sounds a little technical, but once you see the pattern, it's very easy to go after. And I think it's much more expressive and much more flexible than just a normal if let.
Yeah, I've seen this technique. I guess actually you do this technique
often, yes,
often enough, and yeah, I kind of started to like it because I knew about pattern matching conceptually. I wasn't like actively using it. I guess like Andrew, coming from Objective-C background, I'm like, there are problems, so I probably don't want to use that, right?
Yeah.
But
yeah, I like it. I'll start doing it.
And of course, it goes on much further in Swift. In Objective-C, the possibilities for pattern matching are pretty much only on integer types, right? So you would have an enum, do a switch, and that's all you get, right? Versus in Swift, one of the things I really like to do is build tuples in the switch. So you would say like switch, build my tuple with these items, and then in the cases unpack all of those. Be like, okay, here's all the possibilities that this tuple might have, and then do whatever complex logic I needed with that. Now that again may sound a bit technical, but it really helps to clean up all the logic that you might have around, like, okay, in the case that this one is nil, but this one is here, and this one is of this type, then I need to do this thing. I'll just call this function and pass the stuff that I need. switches and pattern matching help to clean all of that up.
Okay, thank you, Kyle. It was great. I think we should continue this conversation. There is more to talk about. I want to ask about pattern matching and where it's coming from. So maybe next episode. So yeah, let's wrap it up. Do you have anything to say to our audience? Maybe,
anything to close with?
Self-plug.
No, not really. But if you have any questions about iOS dev or potential opportunities for my future prospects and future career, please feel free to send me an email at kyle@kyleroucis.com. That's KYLE at KYLEROUCIS.com.
Hit him up, guys.
Yeah.
Alex tells me
he's good.
He's strong. That's what Alex. I haven't had the chance to work with him.
I have a high bar.
Hit him up, guys.
As you know.
All right, guys. Thanks so much for listening. Find us on Twitter at InsideIOSDev and send us any questions or feedback. Take care. Bye.
Bye.